Hey, what is up everyone? My name is Sagar and we are back here with another video. And this is the lecture number 6 of our Java and DSA course. And in this particular video, we will be learning about bit magic. And sometimes it is also called as bit manipulation. Doesn't matter what it is called, let's get started. First, I will create my lecture 6 class. And generate main method. So we had an overview how numbers are stored in the form of bits. Let's get deeper into it. So first of all, let me tell you how can we convert binary number to decimal and decimal to binary. Suppose I have an example here. This is a decimal number 518. So I will write here 10 because there are total of 10 possible values in decimal numbers, that is 1 2 3 4 5 6 7 8 9 0. So how can we calculate a decimal number? I know you learned all these things, but just let me tell you. So we all know that this is the ones place, this is tens, this is hundredth, and so on. So we have to write it as this: 8 into 10 to the power 0. Because 10 to the power 0 means 1, and after that we have 1 on our tens place, so I can write it as this: 1 into 10 to the power 1, and after that 5 on 100th place, so I will write it as this: 5 into 10 to the power 2, that is 100. As you can see, power is increasing by 1, and that is a power of 10 because there are a total of 10 possible values. So this is 500 plus this is 10 plus this is 8. 8 into 1 is 8. So 500 1 8 518. That's how we calculate decimal numbers. But you already know that. I am telling you all this because this is the same way we calculate binary numbers. Suppose I have an example. I have this 101. This is a binary number, so the total possible values are 2, that is 0 or 1. So this is on ones place, so I will write it as this: 1 into 2 to the power 0. Why? Because 2 are the total possible values, and after that this is 0, so I will write here 0 into 2 to the power 1, and after that we have again 1, so I will write here 1 into 2 to the power 2. As you can see, 0 1 and 2. So this is 1 into 2 to the power 2, that is 4, and after that this is 0, so we will not count it, and 1 into 2 to the power 0, that is 1. So 1 plus 4 is 5. That is easy. You can cross check. This is 2 to the power 0, 2 to the power 1, 2 to the power 2. We learned all this in our previous videos. So this is 4 and this is 1. The outcome is 5. Simple as that. Here we are always multiplying with the power of 2 because there is only pairing of 2 values, and in our decimal values there are pairing of 10 numbers, and that is why we are multiplying all these with power of tens. So that is how you can convert binary number to decimal. And now let's see how can you convert decimal to binary. So there are multiple ways, but let me show you all one by one. Suppose I have number 14, so I will write it as this: divide it with 2. So the quotient is 7 and the remainder is 0. Again divide with 2. Quotient is 3 and the remainder is 1. And again divide it with 2. Quotient is 1 and the remainder is also 1. And now it is less than 2. That is it. Now this is your binary form. You can write it as this: 1 and then this one and then this one and then this 0. This is your binary form for 14. You can also cross check this. This is 2 to the power 0 1 2 3. 2 to the power 3 is 8 plus 4 plus 2. and that is 14. So this is the first method, and now let me show you another one. Suppose you have a number 13. So as you can see, this is an odd number. So first of all, you have to set your first bit. Why? Because this bit is used to represent either a number is odd or even. And if this bit is set, that means there is 1, the number is odd. And if there is 0, then the number is even. And after that, we have here 12. And after that, we have to divide it with 2. And after dividing, we have 6. 6 is an even number, so we will write here 0. And again divide it with 2. 3 is an odd number, so we will write here 1. And again divide it with 2. Then we have 1. 1 is an odd number, so we will write here 1. That is it. This is 8, this is 4, this is 1. That is 13. Now let's see some other example. Suppose there is 15. This is again an odd number. So the last bit is 1. And then divide it with 2. The quotient is 7. That is again odd. So I will write here 1. That means when my number is odd, I will set my bit. And when my number is even, I will write here 0. So again divide it with 2. Quotient is 3. That is again odd. So I will write here 1. Again divide 1. That is 1. So you can see here 8, 4, 2, 1. All bits are set. 8, 4, 2, 1. That is 15. So this is the second method, and now let me tell you the third one. So this method is a kind of thinking and not writing, and you will get habitual when you practice more and more of this. So suppose I have a number 17. So your first step is to find the number that is less than 17 and is a power of 2. And here in this case, our number is 16. So I will write here 1, and we know that 16 is 2 to the power 4. So this is 2 to the power 4, and the difference between 17 and 16 is 1. So all my bits are 0, 4, 3, 2, 1, and then 0th bit is 1 because my difference is 1. 2 to the power 0, 0, 1, 2, 3, 4. So this is 16, and that is 1. The outcome is 17. Okay, now let's see some other example. Suppose I have a number 40, and our first step is to find a number that is less than 40 and is a power of 2. That is 16 into 2 is 32. So I will set my bit, and 32 is 2 to the power 5. So 40 minus 32, that is 8, and 8 is 2 to the power 3. So I will also set my this bit. 2 to the power 3 is 1, 4th one is 0, and 2 is also 0, 1 is also 0, and 0th is also 0. So this is 2 to the power 5, that is 32, and 2 to the power 3, that is 8, and the result is 40. I think this is the fastest way to convert some decimal number into binary form, and you can do it efficiently when you are practicing all this. And now let's discuss additions and subtractions in binary form. How addition works in decimal numbers. Suppose I have here 1 and 9, and here 2 and 2. So 9 plus 2 is 11. So there is 1, and the carry is also 1. And 2 plus 1 plus 1, that is 4. So the result is 41. Same as in binary form. Suppose I have two numbers 1, 1 and 0, 1. We know that this is 3 in decimal form and this is 1. So our outcome should be 4. So here 1 plus 1 is 2. And in binary form, we write 2 as 1, 0. So I will write here 0, and the carry is 1. So 1 and 1 are again 2. So I will write here 0, and carry is 1. Their both bits are 0. So there is 1. And this is 4 in binary form. Let us see some other example. Suppose I have 1, 1 and 1, and here 0, 1 and 1. So 1 plus 1 is 2, and 2 is written as 1 0 in binary. So 0 here and 1 is carry. 1, 1 and 1, this is 3, and 3 is written as 1 1 in binary. So I will write here 1, and there is this carry 1. 1 plus 1 is again 2, and it is written as 1 0. So this is 7 and this is 3, and my result is 10. That's it. So now let's talk about how does subtraction work. There is nothing like subtraction in programming. We are just adding negative values. And we already learned that if our last bit is set bit, then our number is negative. In our decimal form, we write it as this, 10 minus 7, the outcome is 3. But in binary form, we can do that. If we are still trying to do this, let us suppose I have an example. This is 5 and this is 2. If I am subtracting them, the outcome should be 3. 1 minus 0 is 1, but 0 minus 1 is minus 1. Things just got out of hand. And 1 minus 0 is 1. There is nothing like this. So if we want to subtract two numbers, then first we have to find the negative of second number and then add it to first number. As you can see here, we are adding minus 7 to my 10 and the result is 3. But how can we find negative inverse of some binary number? The answer is 2's complement. Okay, you have two steps to find 2's complement of some number, and suppose I am considering here integer numbers. Okay, you have two steps to find 2's complement of some number, and the first one is invert all bits, and the second step is add 1 to the inverted number. That is it. Now you can find negative inverse of any number. Suppose I am considering here integer numbers, so I can store 32 bits, and suppose my example is 5 minus 2, so first I will write here 5, that is 5, and all these bits are 0, and 2 is this. All these bits are 0, and this is also 0. So this is 5 and this is 2. So here we have to just add 2's complement of this number with 5. 5 plus negative inverse of 2. Answer will be 3. So let's find 2's complement of 2. Our first step is to invert all bits. Inverting means convert 0 to 1 and 1 to 0. So this 0 will become 1 and this one is 0 and this is 0. All these bits are 0. They will become 1, 1, 1 and all these. So our second step is to add 1 to this number, and all these bits are 1 and this is 1, so it will become 0 and this bit will become 1 and all these are 1 here. So my 5 is there and 2's complement of 2 is this, so we have to add them. All these are zeros and 5 is 1 0 1 and 2's complement of 2 is this. All these are ones and at last 1 1 and 0. So we have to add them. 1 plus 0 is 1, 1 plus 0 is again 1 and 1 plus 1 is 2. 2 can be written as 1, here carry and here 0. So all these bits are 0 and all these bits are 1. So here 1 plus 1 is 0 and after here again carry 1, and as we know all these bits are 1 and all these bits of 5 are zeros. So when we add this carry bit with this number, this will become 0 0 0 and at last we have there carry 1, 1 plus 1 is 2 again and this is 0 and this will go out of range, so we will not consider it, and at last we have here 3. As you can see here, all these are 0, so we can ignore them and the remaining number is 3. As you can see, 2 plus 1 is 3. So that's it. You can subtract two numbers by finding 2's complement of second number and then adding it with first one. And now let's talk about bitwise operators. So we can perform these three operators on two numbers. First bitwise AND, then bitwise OR, and then this XOR. So suppose I have two numbers A and B. All the possibilities are 0, 0, 0, 1, 1, 0, and 1, 1. So A and B. When both bits are 0, the outcome will be 0. Doesn't matter if there is 1. If there is 0, the outcome will be 0. Same in this case, there is 0, the A and B is 0. And here, when both the bits are 1, the outcome will be 1. Now, this thing is looking familiar because we learnt about logical and logical OR in our operators video. Same thing is going on here, and is biased for false values, and 0 is here false. So if both are false, outcome is false. If one is false, the outcome is still false. And if both are true, the outcome is true. And in case of OR operator, here A, bitwise OR B. If both are false, the result is false. If one of them are true, that is, if one of them is 1, then the outcome is 1. Same as in this case, and if both are 1, the outcome is 1. And here in XOR, A XOR B, if both bits are same, 0 and 0, then the outcome is 0. If both bits are different, that is 1 0 or 0 1, the outcome is 1. And here in this case, both bits are same, then the outcome is 0. Simple as that. There are some more operators like this bitwise NOT, left shift, right shift, and then this unsigned right shift. So this NOT operator is used to find ones complement of some number. Suppose I have here 2, 1, 0, and all these 30 bits are 0 if it is integer. And when I use this NOT operator, it will reverse all the bits. That means 1, 1, 1, and here 0, and at last here 1. So this is some negative number. Let us see some practical thing. Suppose I have n equals to 2. First I will print my n, and then use this bitwise NOT and again print it out. As you can see, first my n is 2, and after using this bitwise NOT, it will reverse my all bits and as well as my last bit, and when the last bit is set, the number will become negative. As you can see here, -3. So this was bitwise NOT operator. And my next operator is left shift. Suppose I have a number n equals to 4. First let us see that on whiteboard. Suppose I have a number here 4. So I will write it as 1, 0, 0, and all the bits are 0. And when I use this left shift operator 1 times, that is here you can see n equals to n right shift 1 time. So all the bits in my number will shift 1 times to left side. So that will become 1, 0, 0, 0, and rest of all bits are 0. So this will become 8. Here print n, and after left shifting it 1 time, again print n. As you can see, first our number was 4, and when I left shift it 1 time, the number is now 8. But what happened when I left shift it 2 times? It is now 16. Can you find some pattern here? When I left shift my number one time, it is multiplying my number with 2. And you can see here 4 is now 8, as you can see. And when I left shift it 2 times, it is multiplying my number with 4, 2 to the power 2. Let's run this. As you can see, 4 into 4 is 16. So we can say that the number of time we are left shifting our number, we are multiplying it with 2. So when I write it as this 10, and when I left shift it 1 times, the answer will be 20. As you can see here. So in place of using arithmetic multiply operator, you can use this left shift operator when you want to multiply some number with 2 to the power. So here we can have a conclusion that when we have some number x and we are multiplying it with 2 to the power n, then we can also write it as this: x left shift n times. This is the same thing. And now let's talk about right shift operator. So right shift, when we have a number 1, 0, that is 2, and all the bits are 0, when I use right shift operator one time, it will shift all my bits one time, so it will become 1 and rest of all the bits are 0. So let's say some practical. If I have a number n equals to 2, then I can first print it out and then n equals to and right shift 1 times. So as you can see, first our number was 2, and then after right shifting all the bits, it is now 1. As you can see here, this is 2 and now this is 1. Okay, let's see some another example. Suppose I have here 20 and right shift it one time, it will become 10. As you can see here. And when I right shift it 2 times, hopefully it will become 5. And as you can see here, 20 right shift 2 times, it will become 5. Can you find a pattern here? Same as in left shift operator. If we have some number x and we divide it with 2 to the power n, we can write it as x right shifted n times. This works totally same, but this is the faster one. So when you want to divide some number with some 2 to the power n, then you can write it as this. Suppose I have here 32, I want to divide it with 8, so I will write here 3. 32 divided by 8 is, as you can see, 4. You can also write it as this. This is the same thing. You can see here 32 and 4, and this is also the same. (32 and 4). You can also play with negative numbers. Suppose I have here -6 and I want to divide it with 2, then I will right shift it one time. As you can see, -6 will become -3. Remember, these are unsigned shift operator. That means the last bit, that is a sign bit, will not shift left or right. It will remain on the place. So here -6 is -3. But when I write it as this is called as signed right shift operator. Let's run this. and you can see minus 6 is now 2147 some number. Now this is because this is an signed right shift operator. So here it is also shifting the last bit, that is a sign bit. So here in this case, this is an integer number, so it is on my 32 place, and after right shifting it one time, the number will become positive, and now it is on 31 position, and 2 to the power 31 is some large value, as you can see here. So this operator works the same for positive numbers. As you can see here, plus 6 will now become 3. As you can see here, but when we are using this with negative numbers, it will also shift the last bit, so the outcome will totally change. You can see there. Okay, now let us see some cool things. We learned that the last bit is used to define whether a number is odd or even. So how can we use this property? We can use this with bitwise operators. Suppose I have a number n equals to 23. If my number is divisible by 2, that means it is even, else it is odd. We learnt about conditional statements in our previous video. If you don't know about this, don't forget to check out that one. So here we know that if our number is divisible by 2, that means it is even number. But how can we use the property that if last bit is set, that means if last bit is 1, that means it is odd number. And if last bit is 0, that means it is even number. N and 1 double equals to 1. Double equals to is a comparison operator, and this is a bitwise AND operator. But what does that mean? N and 1. That means we are using AND operator with some number and our 1. So suppose I have a number here 1 1, and I am using AND operator with 1. And we know that AND operator only return 1 when both the bits are 1. So here both the bits are 1. So there is 1 and 1, and here is 0. So it will return 0. Rest of all bits are 0. So in result there will be also 0. As you can see, the answer is 1. We can see here our number was 2 plus 1, that is 3. So we are writing here as 3 and 1. 3 is our input number, and 3 and 1, it will return me 1. So if my outcome is 1, that means my input number was odd. And if it is not 1, then it is 0, then the input number was even. So if n and 1, n is here 23, 23 and 1, that is 1. So if it is 1, then the number is odd, else even. So let's run this, and the answer is odd. So let us take that number from our input, c dot next int. Suppose my number was 1 2 3, that is an odd number, as you can see. So we can use this bitwise AND operator to find whether a number is odd or even. So that was just a cool thing I want you to know. And now it is time for our practice problem. So today you got the hard one. And the first step is to take one character input, or we can say take one single character string input and then typecast it into char. We learnt all this, how to typecast some value and how to take some integer input. And the second step is to change the case of the character. What does that mean? That means if we have small a, then we have to change it to capital A, and if we have capital A, then we have to change it to small a. I think we have to do some modifications with ASCII values. Okay, but we have to do this only using bitwise operators. Now that is a thing to search. So you have to do some research. You can take help from Google or Stack Overflow and then print out the resulting character. And also the first one to share the code in the comment section will get a huge shout out in the upcoming video. So that is it for today everyone. Hope you like this video. Subscribe to our channel and share your views in the comment section. And I will see you in the next one.